Okay, here's another example of solving systems of equations graphically. And we've got 2x plus y equals 3, that's equation number 1. And we've got x minus 4y equals 6 as equation number 2. So the first thing we do is graph each equation. So for equation number 1, we'll set up a mini t-chart here. This is equation number 1 if we want to label it. And we check our zeros or our intercepts. So when x is 0, it's y. When y is 0, it's x. So when x is 0, we just 2 times 0 is 0, so we can just cover that up, and we have y equals 3, so that's nice. And then when y is 0, when y is 0, x equals 2x equals 3. So if I divide both sides, x equals 3 over 2. Which is the same thing as 1 1/2. Okay, or 1.5. So let's graph that and see what that's going to look like. Now you need graph paper, especially when you're going to be doing fractions, but you can usually eyeball the fractions. Okay, so we have x is 0, y is 3, so there's my point there. Hope you can see that. And then when y is 0, x is 3 halves, that's 1 1/2, so it's going to be right in the middle. And with good graph paper, you can get a pretty accurate graph. So we'll connect those 2 points. Try to be careful because you're going to try to get a graphic solution, so if it doesn't go right through the points, you're a little bit off. Your solution would be a little bit off. Alright, so that's the trick. So I put my pen there and there and make sure it's going through the points. So that looks like that's equation 1 right there. And you can get graph paper online, so that would probably be good to download some graph paper. I don't have any on my site yet, but I'll try to get some up there. Anyway, take a look at that. Try to find some good graph paper. Okay, let's take a look at equation number 2. And again, a little mini t-chart here, and check our intercepts, x, y. Remember, these equations are what we call standard form, ax plus by equals c, and when they're in standard form, it's easy to do the intercepts. And when x is 0, y is negative 6 divided by 4, so and that reduces to be negative 3 halves. So I could write that there, negative 3 over 2, which is negative 1 1/2. And then when y is 0, that's nice. When y is 0, x is 6. Okay? We just cover that up, and x equals 6. So let's graph that line. So when y is 0, x is 6. So that's going to go all the way out over here. That's going to be the point 60. Just barely made that on this graph. And then when x is 0, y is negative 1 1/2. So there's my point there. And then we'll try to connect those and see if we've got a solution. And again, set your pen on each point, and then put your ruler in there. And there we go. And again, that's equation number 2. And I can just label that if I want. X minus 4y equals 6. And this is equation number 1 over here, and I can label that 2x plus y equals 3. And where they intersect, that's the solution. Okay, this is the point that satisfies both equations. If you take any x and y on this blue line, it will 2 times the x plus the y will equal 3. If you take any x, y, any coordinate, any point that's on these, remember, there's for each point on this line, there's a coordinate, there's an x and y coordinate. If you take the x minus 4y, you'll get 6. And this is the point that satisfies both conditions at the same time, so it looks like that's the point 2, -1. And you could put 2, -1 in here, 2, and then -4 times -1 is 4, so 2 plus is positive 4, so 2 plus 4 is 6, so that satisfies that equation. And then you can put 2, -1 in here. 2 times 2 is 2, and I'm sorry, yeah, 2 times 2 is 4, pardon me, what am I saying? If I put 2 in here, 2 times 2 is 4, and then 4 minus 1 is 3, so it satisfies both conditions. Okay, so if that makes sense. Sorry about that little faux pas.